We're good? Are we good? Okay. Hi, everybody. I hope you're having a great time so far. And today I want to talk to you about the Go tool and its impact on development productivity for Go developers and about the development productivity in general. So for a brief introduction, my name is Dusan and I come from Belgrade. I'm a software engineer at TruckTrack, and I'm also, like Ayat said, I'm co-founder of the Go meetup group in Belgrade. And I've been doing Go for almost 2 years now, and what really drove me to it was not its usual kind of like pitch moments, or people like to say the Go is all about concurrency, Go is all about efficiency. What really drove me to Go is the simplicity of it. And coming from like 5 years of Java background, the simplicity is something that I really needed at that point, and I felt that my coding was efficient again. And whenever I was doing on some problems, working, and I never felt the code burnout, you know, and whenever I finished something, I still felt the urge to continue. And that is maybe what I would call myself, like I felt productive and I felt efficient. That is what I like the most about Go, is its simplicity and how it allowed me to be more productive. So what is development productivity for you? Some would say that it's just the ability to perform long or repetitive tasks with ease and stress-free efficiency. And how can a language be productive, or how does it provide productivity? People would say language features. Like you have language which supports multiple paradigms. You can do functional programming, you can do object-oriented programming. You, I don't know, you have generics, you have a lot of stuff, but aside from language features, what really is also contributing to the productivity a lot is the language ecosystem and its environment. And with that, I mean all the, first thing, the community that comes with the language, like how supportive the community is, how the tools are, how the editors are supported. Is your development cycle good enough for you to stay focused on the task that you're doing? Like from the moment that you're writing code to the moment that you're compiling it, executing it, testing, and doing the writing again in your next development cycle. Like, did you lose your train of thought? Did you feel burnout or anything? Like the timing needs to be as fast as possible. So to talk about productivity, I wanna mention how the history of development environment was through the years. So in the beginning, everything was done in the terminal because there was no graphical user interface. You know, we all started doing programs in the terminal. And in the 90s, where graphical user interface was introduced, initially everybody wanted to shift that and use that benefit to empower the productivity of development. And people started building IDEs, those big applications which allowed you to manipulate your code, totally, like build it, run it, test it, debug it, everything in it, like for code completion, whatever. And people embraced it for the simple reason that you didn't have a lot of variety at the time, and you had your IDEs were only focused on particular languages and particular platforms, and they were supported and funded by big corporations which were actually pushing the development of languages. But in the recent years, we have this change in the environment with the rise of the GitHub and the strength of the open source software. The community is taking the control of development of languages and platforms, and individuals like that don't have the means to build these kind of big graphical applications to empower the development. Instead, they're building the smaller tools, which everybody can use and everybody can run from the terminal. So we have this trend that people are going back to the terminal. in this day and age. And people run code from the terminal, people lint their code in the terminal just for checking errors, people test their code in the terminal, people even write code in the terminal as Vim is at its all-time high popularity. In this day and age, it's amazing. So it's just a really weird transition back and forth, and how the terminal is really playing a crucial role in today's development productivity. So how does Go fit in all of that? So Go basically was designed with productivity in mind. So Go was actually, there was an anecdote there that the idea for Go came around when people at Google were waiting for C++ program to compile. So what they wanted to do is make a programming language that is more efficient, and efficiency would come in these three categories, which is fast development, which would be the time from where you're writing your code to the time that you actually begin compiling it. You have the fast compilation, which is, just the time your code builds and compiles. And I mean, you have a lot of interpreted languages right now, dynamic languages, which have no compile time, but that is really slowing up the execution, which is also very important because the execution is not only important to you as a developer while you're running your code and testing it, but also for your users, and for your, that means for your money and your company's money. And Go had the idea, we're gonna be good enough in all three categories. We're gonna create a language which has a very simple feature set, very simple and familiar syntax to most of the developers, so they could develop fast. We're gonna make a compiled language, so it's not gonna be interpreted language, because compiled languages generally run much faster than interpreted languages, and that means Go does not run on any VM, not LLVM, not JVM, it runs natively. That makes it very fast. And the fact that it has very fast compilation compared to C or C++ gives him a win in the second category. And the fast execution, which, like I said, it's a compiled language, it runs natively, and it's gonna perform much faster than all the interpreted languages. So basically what we have is an overall very good programming language, which is good enough in all three categories. It doesn't have the fastest development time, because a lot of other languages, like Ruby, are still better for fast prototyping. You can still do things faster than that, but Ruby is hella slow. You still have faster compile languages. I mean, not compile languages, but I mean interpreted languages, which basically have the 0 compilation time, but they lack in execution, and Go is good enough in execution. It's not the best. It's still outperformed by C++ or Java, but coding in C++ and Java is hell of its own. How does Go achieve that? Go achieves that by setting very strict rules or development guidelines that every developer must abide to. And in a way, it's kind of reinventing the development environment, because usually in all other platforms, whatever tools you're using, whatever languages you're using, you can always configure how they work, how they're gonna behave. Like in JavaScript, if you use any of 300 linters that are out there, you can configure each and every one of them, which errors should they ignore, and which things they should report as an errors. In Go, you don't have configuration for anything. You only have conventions, which means that the Go team set up these conventions that everybody must abide to, and there is no discussion about it. So you don't have a make file to tell your build tool how to build your program. You don't have a configuration how to reformat your code with Go FMT. You don't have a configuration for your linter to say how to lint your code, which errors to ignore. And what does it achieve? I mean, why have so strict rules for coding, for development guidelines, and for these conventions, when you would think about it, like it's much easier for the user to configure everything as he wants it to be. Like he would be more productive if he has control over it. He would be more productive if he's using the tools the way he wants them to behave. So why is convention better than configuration? And the answer is easy. It's achieving coding standard through consistency. That means that every Go program, every Go project is gonna abide to the same coding standard. And wherever you go and you look at the Go code, that project is gonna be organized in the same way as every other Go project that you've seen so far. Its code is gonna be formatted in like every other Go program that you've seen so far. And that's not gonna make your garbage code less garbage, but it's gonna make the people who are looking at your garbage code have less of a problem. So like they'll understand it better and easier, but it certainly helps. I mean, I know when I'm reviewing some code and the code can still be bad, but at least it follows a certain standard that I can understand. So let's talk about how the Go tool actually works in achieving all of that. So what is the Go tool? Go tool is basically what I call it the Go tool. It's actually Go tools, or people call it the Go tool chain, whatever. It's a collection of command line applications which allow you to manipulate, organize your project, your code, and just the way you type your Go programs. It is actually, they go either included in the Go binary, which you get when you install the Go language by itself, or they have their standalone versions, which are like advanced versions of them, which have some more extensibility options. So what you actually need for the Go tool to work and to give you any benefit of its doing its thing is that you have to set up your Go workspace, and that the Go workspace is basically the only configuration that you need for you to like run Go programs and run it. And that is because Go does not work as a project-based language. It's actually a workspace-based language where you have one workspace folder where you have all your sources, all your compiled libraries, and all your compiled executables at the same place. So whatever code you're writing is going to be in that workspace, and whatever code you're downloading as dependencies is going to be in that workspace, and whatever you compile is going to be there. And it's very easy because in that way all the code is going to be at the same place, and you always know where it is. It's not scattered across your project, and your executables and all your libraries are all there, ready to be used or imported. So the pro tip would be there to set your Go path, which is the environment variable for your Go workspace, to set it as your home folder, because then it's going to be always under your hand, and all the binaries would be in your like home folder /bin, so that you can execute them immediately. So the first two tools I'm going to cover are build and install. Build is something that, like every other compiled language has, it basically compiles your program, your package, and outputs the executable binary if it has executable code in it, of course. But the install tool will also does the same thing as build, but instead of outputting the binary where you told it to output the binary or in the local folder, it is actually going to install it to your workspace. So when you install a project or install a library, it's going to be transferred immediately to your workspace, so you can then import it in your other projects, or you can just invoke it from your command line. One great thing about Go and its build process is because you can cross compile. So even if you're running on Mac or Linux, you can still build binaries for Windows just by setting the few different build flags, and you can have your Windows executable at there. So you don't need a Windows machine and rebuild the program on every operating system that you need to run on. You can just everything do from the same machine. Run and test. Well, run basically does what it says. It runs the program. And what's great about it, it's people are maybe so used to having the run option in all the programming languages, but in Go, it's a compile language. So run will basically make it seem like it's an interpreted language instead of a compiled one, because the run will compile and run at the same time. And because of the Go's fast compile times, you won't even see the difference when running Go program and some other interpreted language. The only convention when running files is that a source file must have main function declared in order to be run and executed. So you invoke it with go run, and you specify the files and arguments, or optionally build flags as well. Test, on the other hand, runs tests, of course. I mean, what else would it run? And the convention there is that all your tests have to be named properly. So your file names have to have the tests underscore test suffix to be treated as tests. So if, for example, your Go code is in a file called hello.go, your tests would be in hello underscore test.go. So whenever you run Go test, it will execute all the tests in the test files. You can invoke it on either files, or you can invoke it on repositories, other packages, or your current working directory. Okay, Go doc, which we already heard a little bit about this earlier. So Go doc will print you all the documentation for the specified package or symbol. Basically, that means whatever documentation you need, you can just type the Go doc in it and get the documentation for it. Which is really good, because I think the Go is one of the most documented languages so far, because of how the Go developer guidelines are making you, or forcing you in a way, to always document your code. And yeah, so like I said, you can invoke it on either package or a symbol, so you can either print out the documentation for the whole package, or a specific function, or a type, or whatever has the documentation, and whatever is exported, actually you can print out the documentation. I did mention that few tools have standalone versions, and GoDoc is one of them. And great tool about GoDoc without the space is that you can also run a web server locally, which will serve all the documentation from your workspace. So everything you have in your workspace, as I mentioned, and you will have everything in your workspace, like everything you download as dependencies, everything you build, and all the Go standard library code, it will all be in your workspace. So you can run a documentation server by invoking GoDoc with HTTP parameters, and then you can have like an offline documentation website when you can check all the documentation for all the code you have in your workspace, which is great if you're working on the run, or if you're going out working in the nature where you don't have internet or whatever, on a plane or a train, while doing just whatever outside. You can still have all your documentation right there in a very friendly, readable mode. Next one is GoGet. GoGet is both loved and a hated feature of Go, because it acts as a dependency manager, but it's not quite a dependency manager. So it acts as, how it works is just it downloads all the projects that you want to use as dependencies and installs them into your workspace. And it is basically the equivalent of git cloning the repository you want to use and then running Go install. Why is it hated? Because it's still lacking features and it's not really a fully dependency manager. I mean, compared to some other very mature tools like NPM or Maven. But recently they added vendoring, so you can actually move all the dependencies code into your project directory, so that even if you accidentally update or overwrite the dependencies in your workspace, all the project files will still be intact. But I think that they're going to come up with a versioning solution as well, because Go team, I mean, there have been a lot of like community tools that have risen recently that try to fix the dependency manager problem, but I think that the Go team really likes to have all these necessary tools under their belt, and that they like that the Go tools are standardized, and I think they're going to come up with a really great solution for this. GoFMT, another tool that we already heard about. Like we already know, it just reformats your code to your Go coding standard. It's gonna replace the file that all the files in your project, in your like package, I mean, with the reformatted code, which is always going to be the same. So you cannot configure it. There is no way to tell GoFMT to act differently. Like you cannot tell it to use tabs instead of spaces, or to use, I don't know, 2 spaces for indentation, or how if the spacings before or after brackets should be there or not. So it's always going to be the same. But I want to mention the 2 standalone versions of GoFMT, which is the GoFMT without space, offers more extensibility, because if you run the GoFMT directly, like not from the Go tool, you can you don't have to overwrite the files that you're using. So you can instead just write the output to your standard output. I mean, output it to a console. So if you can use the GoFMT to integrate it into other software. You can also print out diff, like to see what the changes are made if you don't want to actually do the changes. And there is Go imports, which is used to add or remove imports automatically. Like, I don't know if you know, but unused imports will produce a compile error in Go, which makes you write a really, really better code. So Go imports will not only do GoFMT for you, but will also remove unused imports or add imports that are not already being imported. GoFix will, GoFix is not something that you use every day, because GoFix will go through all your source code and see if your code uses the old API of some stuff in the Go standard library, and just rewrite your source code and adapt it to the new version of the Go standard library, which is really great because it actually allows you and makes it easier for you to update your Go version frequently. And that is something that you really should be doing all the time, because Go is constantly improving, and each new version is not adding more features, just improving the current ones. And for example, each new version is bringing better compiler and better garbage collector latency fixes. So GoFix is just an easy way for your code to be, how to say, migrated to a new version, and it actually encourages you to upgrade more often. I mean, you should do it every time. Every time there is a new version of Go, you should just do it. Okay, so sorry. So we have now we have our linters Go, which are tools for code analysis and error checking. These are very common with a lot of other languages and platforms, but they're, like I said, very community driven, and they're very configurable. So they're not really offering you any standard how your code is linted and how your code is error checked. So, and Go has like 2 linters, as I like to call them, which are lint and vet. Lint will show you all the compile errors before actually compiling the code. So you don't, if you're, for example, running a bigger application, developing it, which may take a bit more time to compile, you can always just use Lint to tell you all the errors. And if you're integrating it into an editor, Lint will always tell you if you missed something. And it will also force you to, not necessarily, but you should do it, just write documentation for all your exported types. Vet, on the other hand, does not check on compile errors, but it actually looks for errors potentially caused by your code. So those errors will not be caught by a compiler, but it will probably result in an error. Probably, I'm saying probably because not always. Vet can provide some false positives, but also some false negatives. What it's looking for is suspicious code constructs, something like unreachable code or shadowed variables or using different types of values when rendering some templates, stuff like that, which will not be an error in itself, but it may produce output that you don't really want, you know? So I recommend just using both of these tools in your editor all the time, just as you're using GoFMT. Okay, we have GoGenerate, which was one of the latest features introduced in Go. I think it was in Go 1.4, and they didn't add any significant new features the last 2 years. It was introduced, in my opinion, to just mitigate the lack of generics. So because lack of generics just means that people, for some cases, and if you rely a lot on interfaces, which you should, you would have to write a lot of code to just implement those interfaces in all the cases that you need them, which is very tiresome when you're writing tests. Because all your functionality should be written to an interface, and you have to mock all of that in your tests, which is why GoGenerate is great, because it can generate code based on the directives you write in your source files. So you write them as tagged comments with // GoGenerate, and then you give it some shell command that it needs to execute for the current file. And like I already mentioned, it's commonly used to just mock interfaces when writing tests. So you can have an interface with all its functions declared, and then just add a GoGenerate command, and for example, some external tools, like in this case, the Mockery, which is a great tool for mocking interfaces. You can invoke it, and it will just generate the mock implementations for you. I mean, you can meddle with it later, but it will just relieve you of writing all those implementations by yourself. It can be boring, and it can be boring, and it's really one of the things that are really tiresome in Go is writing a lot of code to just avoid the lack of generics, and GoGenerate is just there to not fix you that. It's not there to fix lack of generics, just to help you cope with it easier. It's there to generate code. That's it, because you don't have to type it. So that's like a productivity +1 right there. Other tools in the Go tool chain, or the tool belt, whatever, that I have to mention here is GoPresent, which has become like a standard bit among Go speakers. People use GoPresent to create slides and to create presentations like this one, where you can actually embed Go code and execute it inside the presentation, which is very awesome when you're showcasing and when you want to pitch your new language to someone. Being able to execute the code from the presentation is just awesome. And also there's Go Playground. I don't know how many of you know what Go Playground is. It's basically the sandbox environment where you can execute the Go code for testing. So with Go Playground, you can run the same sandbox environment for you locally. So if you want to just mess around, try some new stuff, you don't have to write new programs to just try it. You can just run the playground and test everything out there. Beside that, there's a lot of refactoring tools, like things for renaming, retyping, a lot of benchmarking, profiling tools, also language parsing tools, handling the abstract syntax trees. Like, it's all in the Go tool belt. If you're interested in that stuff, check it out. But that's not something that you're going to be using every day in your Go coding. So if you're not 100% into switching to terminal and using all your tools in the terminal, like myself, I have not accepted all of that. I do not use Vim. So how does Go integrate? Well, I mean, how does Go integrate with editors? And I think this guy knows the answer. So GoTool is very editor friendly, because with a lot of flags that you can put when executing GoTools, you can specify to just write the output to standard output, and just use instead of actually manipulating your code, instead of actually just changing your workspace, you can just buffer it and then let the editor do its work. So yeah, it's easily embeddable with that, and a lot of great editors already, because it's how easy it is to implement a plugin that supports Go. A lot of great editors and IDEs, if you're still into IDEs, have a great support for Go. Like Atom has a great plugin, also Sublime, IntelliJ, you know. They all do have great Go plugins already. And two other tools that are just community maintained. It's not officially under the Go tool belt, you know, but I have to mention them because they provide an enormous help for editor integration. Is the Go code. First is the Go code, yeah. It's an autocomplete engine, which basically just scans what you're typing right now, where your caret is, and provides you with a list of options that you can just autocomplete to, like your local variables, your global variables, your imported packages, and all the functions or types inside the important packages is just very helpful. But I like the GoDef more, which is fine and go to definition. It's very, very useful when you're just learning the language and you want to see how stuff works and you need examples of good code. And like I said, all the dependencies that you're downloading, you're actually downloading the sources, and you also have the sources for all of the Go standard libraries. So you can go dev to any function or type that you're using and just see the implementation for yourself, because Go standard library is the greatest source of good Go code, and you should, like, if you're learning still, you should check out the code in the Go standard library and use it as an example how you should write your Go code. And GoDef really helps you there, because it just flies you there and you can see the implementation right off the bat. But if your favorite editor does not support Go, I encourage you to write one yourself, or not. I tried it, and it's really fun. I tried it for brackets. It's really fun. It just gives you a way to really know better how the Go toolchain works, how the Go code works. So it will give you a different perspective, but you probably don't wanna deal with that. So that was basically it. It was short, but I hope sweet. And thank you, everybody. Do you have any questions? No questions? Great. We have a question.
About the tools, I saw that they are like a project scope, but are there tools that like check, for example, differences in APIs of two projects, for example?
You mean like the Go fix that I mentioned, or?
Like you have, like it is very often that for a Go like a project that one commit can like remove one function that is like exported and used by different
Okay, I know what you mean. I don't think that it can automatically. Oh yeah. Well, he asked like if some library that we used is changed, or we remove some of the used functions in another project, and we actually compile it and we install it to our workspace. How will it affect the program that is already using it? It will break it. That's that simple. Yeah. So it won't have, you won't have like any notification. But what you can do to alleviate that, you can vendor all your dependencies in your other project, so that when you're using imports, it always uses the vendored code instead of the one from your workspace. So you can change your workspace however you want, but the vendored stuff will always stay the same within the project. Anything else?
Yeah, just like there is another tool, I don't know if it would help for this case that you mentioned. It's a Go Oracle, now renamed Guru.
Oh, okay.
It would actually tell you, you point it to some place in your code, for example, a method, a variable. It can tell where it was defined, if it's a method, it can tell which interfaces it implements. So you can find basically everything about the code at hand. So it might be useful to find, for example, where a function is used before you rename it. I don't know if it will help.
Yeah, yeah.
Is there some reason, or maybe a story, why Lint is not part of everything else?
Probably, but I don't know. It's still an official tool. Like it's.
Repeat the question again.
Yes. Why is Lint not the part of the Go binary? I don't know the exact reasons, but it's still the product of the Go team. So it's an official tool. It's not something that community provided. But I don't know the exact reason why it's not included in the binary. Maybe it will at one point, but I have no idea why not. One more question, sorry.
Can you upload the slides online?
Yeah, I will put them on GitHub. Yeah, no problem. Okay.
Thanks again.
Thank you again, everybody.